Today we're going to talk about day 4. I know the notes say day 2. Let's scratch that out. Rearranged a lot. It's day 4. All right. Now we've talked before about positive correlation, negative correlation, no correlation. The positive trend when all the points in the scatter plot were roughly going up or roughly going down. Now we're going to use some official words. Looking at the figures, you've got figure 1, the trend is downward. Figure 2, that's interesting. Figure 4, ooh, that's kind of tight. And figure 3 is tight and figure 4 is tight. Now a correlation coefficient measures the linear relationship between two variables. So if R, which is the correlation coefficient, is 1, that is a perfect, it is a perfect positive linear relationship. It means that all the data points are moving upward and you have basically a perfect straight line. So therefore, if you have an R value of -1, that is a perfect negative linear relationship. You will extremely rarely have a perfect relationship. Now, if 1 is a perfect positive relationship and -1 is a perfect negative relationship, what do you think 0 means? It means no linear relationship whatsoever. You couldn't connect those dots if your life depended on it. So with that in mind, and using the top 4 graphs, let's answer the questions. For each data set, for which data set is the correlation coefficient closest to +1? Well, if you look, figure 3 is the only one with a positive correlation. Only in figure 3 are all the points moving upward in a positive direction. So, figure 3. If we were in the classroom, you'd be answering this on the whiteboards and holding them up. B, for which data set is the correlation coefficient closest to 0? Well, if closest to 0 indicates no linear relationship, then you want the one where the dots are all over the place, and that would be figure 2. You can't even see a linear relationship anywhere. C, which data set indicates the strongest negative linear relationship between its two variables? Well, if you look at figures 1 and 4, you see both of those are negative. But which one has its points in a closer line? Which figure has points that are less scattered? Figure 4. Figure 1 does have a negative, this has a negative linear relationship, but figure 4 has a stronger one. This page is taking everything you've learned about all 3 units, putting it together in one equation. You're going to do it all. So here is the scatter plot. Time spent texting is your x-axis. Time spent exercising is your y-axis. First, you need to plot the line of best fit. Now I'm going to do that, and I'm not going to, let's see, it's about there. Right, is it perfect? No, it's not perfect, but it's pretty darn good. There's my line of best fit. Now, second, I've got to find the slope. To find the slope, I need coordinate points. So I'm going to use 0, 9, and I'm going to look at my line and see where my line of best fit intersects grid lines. Here's a good one. And that is at 5, 5. Now, not all of you are going to have lines in the exact same place, and that's okay. So let's set it up. We've got to find our slope. I'm going to write my points. 0, 9, and 5, 5. I expect you to do this on the work that you turn in. I want to see how you get your slope. I'm going to label my points, x1, y1, x2, y2. Now I'm going to do my math. 5 minus 9 over 5 minus 0 equals negative 4 over 5. Now look at my line of best fit. It is going down, so I should have a negative slope. I know we've told you to keep these in fractions, but now for this type of equation, putting something in the decimal is a lot easier to deal with. And that is negative 0.80. So there's my slope, my m. And I'm going to highlight that. There's my m. Now, even though it's not indicated, I'm going to write my b. My b is my y-intercept. My b is 9. I'm going to highlight that too. Now I'm going to put it all together. Remember, I'm going to write it up here. Y equals mx plus b. So I'm going to, here it is again. I'm going to write an approximate equation. Y equals negative 0.80x plus 9. That's using my m, the m I found, and the b I found. Your slope may be flatter and you may use 8.5 as your y-intercept. That's okay. We're all going to be a little different, but that's fine. The important thing is your line of best fit makes sense and your slope makes sense. This is a negative line. There is a negative correlation with these data points, so your slope needs to be negative. Now we're going to play with math. Using my equation, the one that I wrote, I'm going to predict the time exercising for a student who spends 4 hours texting. Y equals negative 0.80 times 4. That's my x value. Plus 9. Y equals negative 3.20 plus 9. Y equals 5.80 hours. Let's see if I'm right. Now, I'm not going to use my line of best fit to find my answer, but I am going to use my line of best fit to see if my math makes sense. So I say for 4 hours of texting, which is, I'm going to use a highlighter so I'm not making too much of a mess, which is right here. And there's where it intersects. And some student spends about 5.8 hours texting. 5.8 hours exercising. And look, that's about what my line shows. So that's a good check. Let's say you forgot the negative sign. So I'm going to do this in black. We're going to do the error. You forgot the negative sign on your slope. Y equals 0.80 times 4 plus 9. Y equals 3.20 plus 9. Y equals 12.20. So let's see if I'm right. Okay, let's do 4 again because that's what our input. I'm going to go up, go up, go up, go up, and it's way up here off the map. That can't be right. So that's when you know something went wrong. So you can use your line as best fit to check your answer. So I'm going to cross through this because I'll use the highlighter. This is wrong. This is right. And that sums up Unit 5-6 applications.